Hi, I'm Bob. Welcome to the 5 Minute Econometrics, a series of tutorials that helps you understand the basic econometric concepts and ideas. We often hear that a model suffers from the omitted variable bias. What is the omitted variable bias, and what are the two conditions for the bias? Today, I will show you the cause of the omitted variable bias through real-life examples. I will also use the simulated data to illustrate this problem. Let's start with a case in my hometown. In the summer, the number of wildfires increases, while the ice cream sales also rise simultaneously. If we regress the number of wildfires on the number of ice cream sales, we may obtain a positive and statistically significant slope coefficient. Could we conclude that the ice cream causes the wildfires? Definitely no, because we miss a very important factor here, that is the hot weather in the summer. It leads more wildfires, and it also results in a higher consumption of ice cream. If hot weather is omitted from the model, we will have a spurious correlation between wildfires and ice cream sales. That is, we find a relationship between y and x1. That is really due to another unobserved factor, x2, which affects y and also happens to be correlated with x1. The definition of omitted variable bias. The omitted variable bias is the bias that arises in the OLS estimators when a relevant variable is omitted from the regression. There are two conditions of the bias. The first one is that the omitted variable is a factor that affects the outcome variable y. It is a relevant variable or factor in the model, but it is omitted for various reasons. The second condition is that the omitted variable correlates with some explanatory variables in the model. Mathematically, the two conditions mean that the correlation or covariance between the omitted variable x2 and the outcome variable y is not zero, and the correlation or covariance between x2 and x1 is not zero either. In our example, the hot weather is a relevant factor behind the wildfires, and it also correlates with the consumption of ice cream. The derivation of the omitted variable bias is as follows. Suppose the true relation is that y is a function of x1 and x2. However, we only observe y and x1. x2 is unobserved or unmeasured, or we just forget to add it to the model. We regress y on x1. In the regression model, the error term mu contains two terms, the omitted variable x2 and the error epsilon. The OLS estimator beta1 tilde in matrix form is as follows. We plug in the true relation equation for y and then have three terms. In the middle term, we find the OLS estimator for the regression of x2 on x1. We call it delta1 tilde. Then we write the expected value of beta1 tilde. Using the zero conditional mean assumption, the correlation between x1 and epsilon is zero. We can simplify beta1 tilde to two terms. We find that it is not equal to its true parameter beta1. The additional term is the omitted variable bias. It comes from the omitted variable x2. it equals delta 1 tilde times beta 2. Delta 1 tilde is the slope estimator from the OLS regression of x2 on x1. It has the same sign as the correlation between x1 and x2. Beta 2 is the effect of x2 on y in the true relation equation. This is the formula for the omitted variable bias. Let's find the direction of the bias. If beta 2 and the correlation between x1 and x2 are in the same direction, then the omitted variable bias is positive. That is, the OLS estimator, beta 1 tilde, is upward biased. On the contrary, if beta 2 and the correlation between x1 and x2 are in opposite directions, then the bias is negative. That is, the OLS estimator, beta 1 tilde, is downward biased. Please download the dataset for this topic, and I will show you an example with the real data. The data come from the Panel Study of Income Dynamics PSID survey. We have collected data on the U.S. workers' wages, gender, education, and other information. Assume that the real relation is that the log wage is a linear function of the variables female, schooling, married, race dummies, health dummies, and age. We can obtain the unbiased estimate for the true coefficient of the female variable using OLS. It is minus 0.16. Female workers earn about 16% less than male workers on average after holding other variables constant. Now, suppose the variable schooling is omitted from the model. The new regression model suffers from the omitted variable bias. The OLS estimate for the female variable is minus 0.09. So the bias is the difference between minus 0.09 and minus 0.16, which is 0.07. The OLS estimate is upward biased. We can verify the direction and the magnitude of the omitted variable bias using the formula we just derived. According to the formula, the bias is the product of the coefficient of schooling in the real relation equation, beta 2, and the coefficient of female in the regression of schooling on all other explanatory variables, delta 1 tilde. Beta 2 is 0.12 in the real relation equation. We need to regress the omitted variable schooling on all other explanatory variables and obtain the delta 1 tilde, which is 0.59. The omitted variable bias equals 0.59 times 0.12, which is 0.07. It is positive. So we verify the formula of the omitted variable bias. Finally, let me illustrate the omitted variable bias using the simulated data. We can generate pseudo-random numbers in Stata and use the data generating process to generate data with particular properties. We first set a seed to any number we like so that we can get the same sequence of pseudo-random numbers each time we run the program. Then we set the number of observations. Next, we generate variables with random numbers. The error term E is from the standard normal distribution. The explanatory variable x1 also contains random values from the standard normal distribution. We generate another explanatory variable x2. It equals x1 plus a random value from the uniform distribution. We construct x2 as a function of x1 so that x1 and x2 are correlated. It is one of the conditions of the omitted variable bias. Then we generate the outcome variable y. This is the true relation equation between y, x1 and x2. Y is a function of x1 and x2 and the error term E. We set the two parameters. The true coefficient of x1 is 2 and the true coefficient of x2 is 3. You can set any numbers for the true parameters. We will compare the OLS estimates with these true parameters we set. We first run the true relation equation model. We regress y on x1 and x2. The OLS estimates are very close to the true coefficients. There's no omitted variable bias. Next, we regress y on only x1. x2 is omitted from the model. We find that the OLS estimate for x1 is 5, which is much higher than the true parameter 2. The omitted variable bias occurs. It is positive 3. We can verify the omitted variable bias formula. The coefficient from the regression of x2 on x1 should be 1 by the data generating process. The coefficient for x2 in the true relation equation is 3 by the data generating process. According to the formula, the omitted variable bias equals 1 times 3. The OLS estimate for the coefficient of x1 is upward biased by 3. Thank you so much for watching this video. See you soon on the next topic. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.